Hello everyone, welcome to Equal To, and this is the 7th episode of our Polynomials playlist. If you haven't watched the past 6 videos yet, you can go and watch that before watching this video. And we have been solving questions from exercise 2.2, right? In the previous video, we solved a couple of questions from this exercise, and we are continuing with that, and we are going to solve the third question in this video. And the third question has 8 subdivisions. So that is all that is going to be for this video, right? Only the third question. And it's quite simple. It's just going to be repetitive for you, and it will get you the concepts very clear, and you can just practice along with this video as well. Okay, so it's the same concept. You have been given a polynomial. Let me just read the question first. Okay, so verify whether the following are zeros of the polynomial indicated against them. Okay, so what is a zero of a polynomial? That we have seen already. A zero of a polynomial is a value that on substituting on that polynomial, the value of the polynomial would become 0. Okay, so if we have a number and that if you substitute instead of the variable in that polynomial, that is in this case x, if the entire polynomial's value, if it becomes 0, then the value that you substituted is called as 0 of the polynomial. Again, this is something that we have seen already. Okay, so I hope you know this already by now. Only if you know this, it's quite easy for you to solve this. Okay, so basically we are going to check if this value to the right that have been given, if this is a 0 of this polynomial. Okay, so how do we find that? You're just going to substitute this value in place of x in this p of x. So p of minus 1 by 3. Okay, so 3 into minus 1 by 3 plus 1. Okay, so 3 into minus 1 by 3 is basically minus 1, right? So minus 1 plus 1, that is 0. Okay, so 3 into minus 1 by 3 is minus 1. It's quite obvious. And minus 1 plus 1 is 0. So p of minus 1 by 3 is equal to 0. And hence you can tell x equal to minus 1 by 3 is a 0. Okay, it's a 0 in the sense it's a 0 of this polynomial. Okay, let me just 0 of the polynomial 3x plus 1. Okay, so that is it. Okay, so you're just going to substitute the value in the polynomial and you're going to check if it comes out to 0, if the value comes out to 0. If that comes out to 0, then it's a 0 of the polynomial. Okay, moving on to the next subdivision, we have 7 more, right? So if you haven't understood the entire thing in the first subdivision, please bear with me. You will definitely understand it by the end of the 8th subdivision, right? And it will be like a practice for you as well. If you want, you can just take a notebook and pen and do along with me, so that it becomes better for you. Okay, so you're just going to substitute the value of x in this polynomial as well. So p of 4 by 5, that is basically 5 into 4 by 5 minus pi. Okay, so that comes up to 4, right? P of 4 by 5 is equal to 4 minus pi, right? Because this 5 and this 5 gets cancelled, so it's just 4 that is remaining. And the value of pi, as we know, is equal to 3.1415, and it keeps on going because pi is irrational. Okay, so 4 minus pi. So 4 minus pi is not equal to 0. 4 minus pi is not equal to 0, and hence this is the value of 4 by pi for p of 4 by 5, right? So 4 minus pi is not equal to 0, hence 4 by 5 is not a 0. Okay, let me just leave it there. I don't want to write polynomial again and again. Okay, so 4 by 5 is not a 0 of 5x minus pi. Okay, so moving on to the next subdivision, p of x is equal to x squared minus 1, and we have been given two values of x equals 1 and x equal to minus 1. Okay, so p of 1 is equal to 1 squared minus 1, so that gives you 0. Okay, so this is a 0 of the polynomial. So p of minus 1 squared is also 1. and 1 minus 1 is also 0. So this also is a polynomial. This also is a 0. So both 1 comma minus 1 are zeros of x squared minus 1. Okay, so both these numbers are zeros to this polynomial x squared minus 1. Okay, so moving on to the next subdivision. So these are quite simple, right? You can just answer them very quickly. Okay, these are easy questions. So p of minus 1, these are two values, x equal to minus 1 and x equals 2, and you're going to check that for the polynomial x plus 1 into x minus 2. So p of minus 1 is equal to minus 1 plus 1 into minus 1 minus 2. Okay, so minus 1 plus 1 is 0 and minus 1 minus 2 is minus 3, and 0 times anything is 0, so that basically turns out to 0. So p of minus 1 is equal to 0. Let us check for p of 2 here. P of 2 is equal to 2 plus 1 into 2 minus 2. Okay, so 2 plus 1 is 3 and 2 minus 2 is 0. So again it becomes 0. So both minus 1 and 2 are zeros of the polynomial. What is the polynomial? X plus 1 into x minus 2. Okay, so that is the solution to the subdivision. Moving on to the next subdivision, we have come to fifth subdivision. It's nearing the end, right? So p of x equal to x squared and x equals 0. It's quite obvious right from seeing it. So p of 0 is equal to 0 squared, which is 0, right? So 0 is a, okay, it's very close. Okay, 0 is a 0 of x squared, right? The sentence is quite ironic. 0 is a 0 of x squared. Moving on to the next subdivision, here we have p of x equal to lx plus m. Okay, so let me just write the question again here. P of x is equal to lx plus m, and the value of x that you want to check for is m by l minus m by l. Okay, so you are basically going to check for p of minus m by l. So that is l into minus m by l plus m. These l's get cancelled and you get minus m plus m, that is basically 0. P of minus m by l is equal to 0. So minus m by l is 0 to lx plus m. Okay, easy. Moving on to the next subdivision here, p of x equal to 3x squared minus 1. P of x equals 3x squared minus 1, and we have two subdivisions here, subdivision inside a subdivision. So the value of x that you want to test for is minus 1 by root 3 and 2 by root 3. So these are the two values, right? So p of minus 1 by root 3 is 3 into minus 1 by root 3 squared minus 1. Okay, so that is 3 into 1 by 3. Minus 1 by root 3 squared is 1 by 3, right? So it's basically 1 minus 1, and that comes to 0. So p of minus 1 by root 3 is equal to 0. Okay, so let us check for the other number as well. So p of 2 by root 3. 3 into 2 by root 3 whole squared minus 1. So that is 3 into 4 by 3 minus 1. 3 and 3 gets cancelled, and 4 minus 1 gives you 3. So p of 2 by root 3 is actually 3. So only this number, only minus 1 by root 3 is a 0 of 3x squared minus 1. Okay, the other one is not. Okay, moving on to the next subdivision, and this is the last subdivision of this question. Okay, so again it's the same. I hope you have been solving along with this video, so you would get a better understanding while you try to do it yourself. So P of 1 by 2 is equal to 2 into 1 by 2 plus 1. So that is 1 plus 1, and that is 2 and not 0. Right, 2 is obviously not equal to 0. So 1 by 2 is not a 0 of 2x plus 1. Okay. Okay, so that is all for this video. So we have solved 8 subdivisions from this question, from which is third question, and you have substituted the values of x that have been given in the question, and you have tried to find if that is a 0 of the polynomial or not. I hope you have got an understanding of what a 0 of a polynomial is, right? I hope you got to know that. So it's quite simple. If you have any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. And in the next video, we're going to see the fourth question of this exercise. With that, this exercise is going to get completed. So you'll see that in the next video. If you have any questions in this video, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.